Hello, everybody. Welcome back to In the Loop. We are a podcast by Texas Guadalupe, the University of Texas Hyperloop team. I am one of your co-hosts, Gavin Nader. I am the head of business, and I am a senior studying economics here at UT.
I'm your other co-host, David Spittler. I'm the head of engineering for Texas Guadalupe and currently pursuing my master's in mechanical engineering at UT.
So today we have a very special guest. It's going to take me a while to get through his introduction because he's got a long resume. But we have Mr. Ondler. Mr. Ondler has 35 years of experience in engineering, management, and leadership, both in government and in industry. He served 28 years with NASA in many different roles. While at NASA, he was the recipient of NASA's Outstanding Leadership Medal and Exceptional Achievement Medal. Matt eventually left NASA as the Assistant Director of Engineering at Johnson Space Center. Matt then went on to serve as a senior executive at Gaffarian Technologies and then started his own robotics company, Houston Mechatronics. He is now the senior technology officer at Axiom Space. Matt, how you doing?
Great. Pleasure to be here.
Yeah, so our first interaction was actually I remember now, it was a required student engineering council meeting that I had to go to. And I had no idea you were going to be there. You just had to go there for hours. So I kind of had it on the background, and then they introduced you. And I'm an avid follower of space. And so when I heard, CTO of Axiom Space, I was like, whoa, what? This is so random. So I'm very glad that I was forced to go to that meeting that one time. But yeah, thank you for being here, and I'm super excited.
Awesome.
So to get started, I kind of just want to learn about your early days and sort of how you got interested in STEM and in space exploration.
Yeah, awesome. Yeah, so I grew up in Casper, Wyoming, which is the largest city in Wyoming, but it's only 50,000 people, so pretty small town, and not exactly a place you would think that someone would come out of and join NASA. But I was 6 years old, and I remember watching Neil Armstrong walk on the moon on my parents' black and white television, and really never wanted to do anything else. In fact, I actually remember having this feeling of anxiety that here we were putting a man on the moon, and I was stuck in the first grade. So really was interested in space from that point on, and in general interested in learning. So I was always curious about learning. I liked history and math and science and really all the subjects in school. But I really liked being able to solve problems, and I thought it was amazing that you could take an equation and predict, how high a ball would go, or how far a cannonball would go with, some basic equations. So I was really fascinated with solving problems and fascinated with space.
So were your parents engineers, or were they involved in STEM?
No, not at all. And actually, I was the first person in my family to go to college. So my dad was a master electrician, but always was building things, and tinkering on stuff. And so I think in many ways they encouraged me, but didn't really know how to guide me. So had fortunately lots of folks along the way that helped get me where I was.
Wow.
So growing up, was the end goal always to end up at NASA or some space related company, or was there early on some question as to what route you might take?
No, I really wanted to be an astronaut. And so NASA was really always the path. It wasn't always clear how I got there. And actually it turned out to be relatively random. I went to the University of Colorado because they had an aerospace program. And at the time it graduated more astronauts than anyone else. And while I was at the University of Colorado, I think my junior year, I happened to be living in a dorm that half of the dorm was career services. And so I happened to be checking my mail one day and saw a flyer for applying to the NASA co-op program or the intern program. And so I did. And, the next year I was a co-op at NASA. And at that time, that was generally how people hired on to NASA. You started in the intern program. So I did a couple intern tours, and then after graduation started full time. But it was sort of I knew I wanted to end up at NASA, but didn't realize that that was the path, through the co-op program. And so I was a bit lucky to be living in that dorm and happen to walk by that flyer one day.
So when you first got to NASA, sort of what was going on at NASA? Was it the space shuttle program? And then sort of what was the first big project that you worked on?
Yeah, so it was the summer of 1986. And so the Challenger accident had just happened in January. And so one of my first jobs was at that time we were looking at different ways to improve the shuttle so that it would be safer. So we were looking at different ejection seat modifications and a thing called a tractor rocket, which is you strap yourself onto a rocket and it pulls you out of the cabin if there was a problem. So those early years were doing a lot of that kind of work, trying to find different solutions for improving the shuttle safety from a crew standpoint.
And eventually, did they include ejection seats in the shuttle?
No, we looked at it pretty hard and decided that it was just too hard and too costly and too difficult to really make those improvements. But we ended up making one improvement, which was called the escape pole. So in certain abort situations, if the shuttle could get under control, but you weren't going to be able to make it to a runway, you would put the shuttle in a gliding flight, and you'd get down to altitude under 25,000 feet. You'd blow the hatch. This escape pole would come out of the hatch, and then each crewman would hook themselves to the pole and slide out. And the pole allowed you to get out of the hatch and not hit the wing, so it got you out and underneath the wing. And so that particular device was put in all the remaining shuttle flights.
I remember seeing tests about that, and it's just a crazy concept.
Yeah.
I also remember, I think there was like a couple or maybe one like abort to orbit. That was the only one.
Yeah.
But yeah, I remember looking at this problem, and it's crazy because there's such a small window for like aborts.
Yeah.
And then I remember reading that if they'd work to do ejection seats, the speed at what they were going would have been like near deadly.
Right. Right.
So I can only
Yeah,
imagine like how tough it was to try to create solutions to that problem because that's a big one.
Yeah. Yeah. And that was a lot of the analysis that I did. So I was initially in what was called the aeroscience branch. And so doing trajectory analysis and those sort of things. And you're right, the window to eject from the shuttle is pretty small. You're either going way too fast, very soon after launch, you're going way too fast, or you're just at way too high of an altitude to eject.
Yeah.
But it is why, there's so much effort on the Orion space capsule and why it has, an ejection capability. Basically, the entire capsule can be pulled off during abort.
Yeah. It's a lot easier with a small capsule, right? Not a huge plane.
Right.
So after, how long did you stay with that program?
We probably worked that for about 2 years. It was about 2 years before we returned to flight. And so worked that probably most of that time. And at the same time, I had other projects. We were looking at building a vehicle that would go to Mars and grab a sample and then return with the sample. It was called the Mars Rover Sample Return Mission.
Very
It was
creative.
always, yeah. It was always a bit underfunded. So, we'd work on it a while and then the program would kind of be revamped and we'd work on it some more. But those were some fun times too, because we were really looking at some interesting problems. Like when you go to Mars, Mars has just enough atmosphere to be a real pain, right? It's not quite enough to really use it, to adequately reentry, but there's enough of it there that you have to deal with it. And so we were looking at different methods of what were called aero capture, where we would skim into the atmosphere, use the atmosphere to slow the vehicle down, and then pop back out into orbit. And then we were looking at that same technique when we returned to Earth. Because when you return into Earth from Mars, you're going about 36,000 miles an hour. So you're about 10,000 miles an hour too fast to be in orbit. So you would enter the atmosphere, use the atmosphere to bleed off that extra velocity, and then pop back out into low Earth orbit. So it was a way to slow the vehicle down without having to carry any fuel to do it.
I've employed that technique many times in Kerbal Space Program.
Yeah.
So is
So
that
was it
actually one of
like
the
being-
first like Mars sample return mission designs?
It probably was, yeah. Still hasn't been done yet.
Yeah, in progress.
Yeah.
So like at any one point, how many different projects at NASA are you involved in? Because it seems like, I mean, it's a couple and then you just keep jumping around.
Yeah. And that group that I was in, which was called the Advanced Programs Office, we were always looking at that sort of leading edge, or trying to solve hard problems like the crew escape system, or how would you put ejection seats, and then always looking forward, like advanced mission design, like the Mars rover sample return. So there was always several mission concepts we were looking at, or problems that would come to that branch to try to solve.
Wow. It sounds like an exciting division to be in. They just throw like the hardest problems at you and you get to workshop them.
Yeah, it was.
So working on all these
after-
projects that were kind of in the early development phase of would they or would they not go on to be a full mission cycle, was there any program that you had wished would have continued on and become like a full scale test?
Yeah, and that one would probably be it was called the Aerosys flight experiment. So we were gonna fly this vehicle up on the shuttle, and it had a rocket motor on it, so it would accelerate to a simulated lunar return or Mars return velocity. So it would be at somewhere around 35,000 miles an hour, and then it would go into the atmosphere and demonstrate this aerobraking technique. And so that project we worked on for a long time. We had hardware being built, and the mission was set aside on the shuttle to fly it, and then eventually was canceled. So that was part of at NASA that you had to get used to, was that there were a lot of programs that never went all the way. NASA is generally underfunded, and so it's just hard to get a lot of the missions accomplished.
Was it ever tough for you was that ever in the back of your mind, like when you started on a new project, like this could get canceled?
Yeah. And actually that's what happened probably about 5 years into my career. And I think this was a great lesson, and I try to manage in the same way. But I went to my boss and said, every year we start up a new attempt at the Mars rover sample return or Aerosys flight experiment, and every year we make a little progress, and then it's canceled, or it's changed into something else. And so I told him that I didn't want to do that anymore. I wanted to do something else. And so he helped me find that other thing, which was a flight experiment called SpyFix. And I always remember that, and I always try to manage all my people the same way, that, it's important that you give people opportunities, and that you don't hold on to them and try to keep them. You help them grow and find other opportunities. And so I always thought that I admired the way he managed the people that in his organization, and always encouraged them and helped them, find other things that were interesting. And so
I had kind of a question along those lines. A lot of engineers don't like to dive into like the leadership aspect or like the management aspect, but you obviously have a very long management experience and leadership experience and even entrepreneurship. So I'm wondering for you, like as an engineer, what excites you about doing management and entrepreneurship, and sort of why do you think that's such a good facet to go into?
Yeah. So first, I always encourage young people to stay technical for at least 5 years, head down and solving problems and working SolidWorks or whatever the particular discipline is, and really become an expert at that. And then if your interest is in project management or managing people, then you have this sort of base of a good technical background. And I probably did that about 10 years or so, and got the chance to work on a lot of different things. So I had a pretty broad background. But to answer your question more directly, when I started my career, I was, a math and science person, and I loved equations and green engineering paper. But there became a point where I really became fascinated with the squishy people stuff, and how do you manage people, and how do you marshal resources, how do you lead and get people all pulling in the same direction, how do you solve a lot of those kind of problems, because those problems have to be solved too. And I even like problems where Sally doesn't want to sit beside Bob, and working through those sort of silly things, but helping people find their best self, and grow in their career. So I don't know exactly when it happened, but there was just a point where I really became interested in being able to lead people, and really shape where the organization went in a different way.
Is that transition pretty natural at NASA to be able to move into a leadership position like that?
No, and I'd say actually NASA probably doesn't do it very well. Generally, the people that get picked for those positions are often the best technical person, in that group, which is a terrible way to pick leadership. If you look at a typical baseball manager, some of the best baseball managers were marginal professional players, right? People like Michael Jordan don't make a very good coach. People that are really good at something don't always make the best coach. And so I'd say NASA doesn't do it very well in terms of who they go and pick. But one thing they do well is the training, and all the opportunities to develop as a leader. There's just tons of training that NASA invests in. They send you off to, week-long training courses, and just a lot of opportunities to develop as a leader once you've chosen that path.
So I know you also went and got your MBA at the University of Houston. Would you say that that was a very important step in your growth as a leader? I know there's some debate nowadays as to the importance of getting an MBA versus the actual just on the site experience. How would you kind of like weigh that?
Yeah. And I did. I got my MBA because I did think I had always been entrepreneurial, and knew I wanted to do something entrepreneurial. And so the MBA was a way to see the world in a different way, and to learn about things that I was also curious about, like finance and marketing and economics and those sort of things. So it was, I think, a valuable experience. And I think all kinds of learning are valuable experiences. Whether you need an MBA or not, I don't know, but there is really some very valuable, specific things that you learn, about finance or economics or marketing, that I think are very valuable if you want to go into the business world. And then in terms of leadership, I think those things sort of help broaden your perspectives, so that you can. One thing a leader has to do is you have to be able to relate to the person's individual circumstances or issues that they have, and so it probably helps me, in an organization like today, where I'm dealing with the marketing folks or the finance folks, and kind of understanding what their problems and struggles are.
We had Josh Geigel on, who's the CEO of Virgin Hyperloop. And he's a pretty similar background, like a hardcore engineer moving into sort of entrepreneur and manager. and he sort of said that it's like a very different happiness when you like it's something to sit down and solve a mathematical problem and like get an answer, but it's like a different sort of experience when you put a team together and you're able to solve a problem together. So
Yeah.
there's definitely something valuable in that.
Yeah. My role now at Axiom. So when I started at Axiom last January of 2020, I was one of two engineers. We only had 17 people in the company, and we were a couple weeks away from winning the Port Award, which is an opportunity to build our space station off of the forward node of the ISS. But once we won that award, then my job has been to build the team. And so now we have 135 engineers on the team across all spacecraft disciplines. The total organization's over 200. And so to your point, it's been just a blast, building the team and interviewing people and hiring people and organizing and getting everyone on the same page and going in the same direction and working personnel problems that are natural when you have a group that large. And so that part becomes, just as fascinating and satisfying as solving the engineering problems.
Do you still do engineering problems?
At a certain level where, when you get to a certain level, your role in engineering problems is more, hey, did you think about this? Or did you verify your analysis through a test? And so it's more guidance and mentoring and asking questions. I'd say that you get to a point where I can tell if a number is too big or too small, but I don't know how to produce the number anymore. I know what SolidWorks does and how it works and all of its nuances, but I don't know how to get on and actually use the tool. So it's more about that. It's more about mentoring and guidance. And also at Axiom, it's about setting a certain culture. And so the culture we want is a culture of rapid development, experimentation, not being afraid to have a little smoke coming out of the lab once in a while, really try to push this idea of build a little, test a little, see what works, what doesn't, not be afraid of failure. And so really it's a lot of pushing that kind of culture.
So speaking of Axiom, I'm interested in sort of what pushed you to leave like the public space industry and move into the private space industry.
Yeah. So I knew I wanted to do something in the private sector at some point, and I got my MBA in 1993, and then still stayed at NASA another 20 years. But I reached a point, been at NASA about 28 years. I was at an age where if I was going to leave, that was the time. Otherwise, it would have just made sense to just stay until retirement at NASA. But I wanted to do something different, and so I kind of made it known that I was looking for a change, and happened to, again, a bit of lucky circumstance. Came across a gentleman named Cam Gafarian. Cam owned a company called SGT, and it was one of the largest NASA contractors that no one had ever heard of. He was always in the top 10 contractors, and besides Lockheed and Raytheon and Boeing, and then there'd be SGT. So he had a large engineering service company. But I really liked Cam's approach. He was dedicated to the NASA mission and wanted to do great things in space, and so it was a natural place for me to go. And so I worked for Cam, did a lot of different things in his business, and then it was Cam really that encouraged me to start the robotics company. Again, another great example of a good leader that isn't trying to hold on to everybody, right? He really wanted what was best for me, and I'd stayed in contact with a couple guys from when I ran the robotics group at NASA, and we had some ideas on robotics, and it was a time in which lots of people were wanting robots and intelligent automation, and so started the company, and really Cam encouraged me to do so.
So, is your robotics company still operating?
It is. It is.
Okay.
We focused a lot in oil and gas, and very early on had customers. Schlumberger was a big customer, and then became an investor in the company. And then Transocean became another investor. Transocean is one of the largest offshore drilling. And we had an interesting idea about a subsea robot that would really change how subsea services are done, and be much more economical for oil companies to develop subsea fields. And then it turned out that robot had lots of applications in defense, and that's really where the company is primarily now, is building a very capable subsea robot, primarily for defense, to be able to take things apart and put things together in the ocean autonomously. But yeah, there was a time period where I and these sort of things happen too, right? We had taken investment from these investors, and they wanted us to go a certain direction, which I didn't think was the right direction for the company and for the people in the company. And we argued over it for most of a year, and then it got to a point where we agreed that it was time for me to leave. And so I sold my interest in the company and was looking around for the next thing to do, and happened to reacquaint with some old friends at Axiom, and really got excited about what they were doing. And so a couple beers later with the CEO, I joined, and it's been fun ever since.
I know you worked on Robonaut 2 during your time at NASA. How important was that and the lessons learned there in kind of the founding of Houston Mechatronics?
Yeah, it was critically important. Much of the Robonaut team are at Houston Mechatronics now, and certainly a lot of that technology that we developed is part of Houston Mechatronics DNA for sure. And that's why I think it was the right time to start the company, is because we realized we were sitting on, some of the best robotic technology, and more importantly, had developed a bunch of really, really capable and smart people in robotics. And so a great team to form a company around, and to go off and try to commercialize some of those technologies. And Robonaut was an amazing machine, probably a little ahead of its time. We flew Robonaut to the ISS, and the idea was it would be an assistant for the crew, and could do things, sort of menial tasks, wiping down handrails. And eventually the plan was to be able to send it out to do maintenance activities, so you wouldn't have to send a crew out. But again, a little ahead of its time. So it's still, that technology is still not quite mature enough to have a practical application, but certainly push the limits of robotics technology for sure. And I always tell people too, someday, you all are sometime in the next 20 years, you'll be able to go to a store and buy a home robot, a humanoid robot that can do the dishes and clean the house, and you download apps to play tennis with it or whatever. And those machines will trace their heritage to Robonaut. Pretty sure, it's just been an amazing vehicle to develop those technologies.
With upcoming lunar and eventual Mars missions, do you hope there might be a Robonaut along some of those initial astronauts?
Yeah, that was always the dream, because the crew won't always be there. And so having a robot that can use the same tools as the crew, and be able to expand the Mars base or lunar base, or to do maintenance when people aren't there. I think those things are very, very important. And also to be able to send it out and do dangerous things. It's still a very dangerous thing to put a crewman in a spacesuit and have them go out and do work. And so anytime you could send a robot to do that, you're better off. So yeah, I definitely think robots, and especially humanoid robots, are in the future of human space flight. And that was really why we built a humanoid robot, is because the world is built for humans, and the International Space Station is built for humans, and future lunar base will be built for humans. And so having a humanoid robot that can interact with the environment in the same way that a person does, it can, open doors and hatches and use the same tools. There's just a huge advantage to having that kind of capability. And plus, the first thing you learn building a humanoid robot is you learn how remarkable humans are. And so our hands, are amazing tools where we can do so many different things. And so building a robot that has that same capability allows you to do all kinds of things, and especially allows you to do things that you didn't imagine when you first built it.
So yeah, along those lines, I wanted to ask you, what do you think like the biggest limitations to Robonaut were? You said it was a little too soon. Maybe
Yeah,
what were some of the limitations that it couldn't do?
it was probably a little, and this is probably true of every technology when it first emerges. It's just a little too delicate, where you got to have engineers that are coaxing it along, or recognize that it's not quite working properly. There would be this indicator. We would have people come into the lab because it was a famous part of the tour, and you'd get to shake hands with Robonaut. And so Robonaut would find you, in its vision system, and grab your hand and do a little squeeze. But we always knew when the demo was close to not working, is there'd be one finger that would start to twitch. And so you'd see the engineers in the background, typing away, trying to reset the Robonaut. And usually we'd be able to do it without the visitor noting it. But it was just a little delicate. And I think kind of true of most new technologies, where it takes a while to really build up robustness and have it be able to be operated by a non-engineer, or
I wanted to go back to your experience with ISS. You were sort of there at the beginning, and you worked on GNC, guidance, navigation, and control. And I think it's kind of funny because maybe when people think of like guidance, navigation, and control for a space station, they're like, it's just, in a stable orbit. What does that mean? So can you
Right.
describe like what you did with that team and sort of why the ISS needs that team?
Yeah. So there's a couple of interesting things about the ISS that I think not a lot of people realize. But when uh, we decided to build the station with the Russians, the GNC system became split between the Russians and the US side. And so now we can't really control the station without both of us. The Russians provide the thrusters, the propulsion system, and then we provide the navigation sensors and what are called control moment gyros. And so one of the reasons you need GNC on a space station that's just boring holes in the sky is that you need to control the attitude of the station. We generally want the long axis of the station parallel to the Earth. So you have to continually change and maneuver the station as it goes around the orbit in order to keep it in that attitude. And then there's all kinds of other constraints too. There are thermal constraints, so we want to control the attitude to protect certain sun angles, and you want to be able to generate enough power so you're tracking with the solar rays, and those solar rays, when you're moving those, cause disturbances in the station. We also have to do debris avoidance maneuvers. Those are actually becoming more and more common. So debris of a certain size is tracked by the U.S. Air Force Space Command, and occasionally they will alert NASA that there's going to be a conjunction or a near, a near miss, and so the station has to do avoidance maneuvers. So it has to, boost to a higher altitude to avoid some of those possible debris events. So those are the kind of guidance and nav and control problems that you have. And then an interesting one is on these control moment gyros. So they're giant wheels. They weigh about 260 pounds, and they're revolving at about 6,000 RPMs, I think. And there's 4 of them. And so those big gyros are what is used to control the attitude. But as you go through the orbit and are constantly changing, those gyros get saturated, is what the term is. And so when they're saturated, we then call on the Russians to fire thrusters to desaturate the CMGs. So it's quite a orchestra between us and the Russians. And one of the things I did was I built a laboratory where we tested for the first time the U.S. and Russian computers and talking together all for the first time.
What was that like I'm sure you had direct contact with them, right? What was that like working with, the Russians in different language across the world? I mean, that must have been an international cooperation.
Yeah, and very difficult, and very soon after the fall of the Soviet Union as well. And so Russia was generally in turmoil. And when you visited, you realized in many ways it's a third world country. It's a third world country with a world-class space program and 20,000 nuclear warheads. But in many ways, it was a very strange experience. And so the meetings were very tedious, translator through the whole thing, because we certainly didn't speak Russian and very few of them spoke English. So it would be, everything took 2 or 3 times as long to work through problems. And then when you're trying to work through technical problems, there was just even the terms or the ways we each solved the problems were so different that it was easy to misunderstand each other. So it took a long time to work through those.
Yeah, that was your introduction to management and leadership, I guess.
Right.
Baptized by fire.
Yeah.
So is the Russian vehicle the only one that can currently do like saturation burns and boost burns?
Yeah. Now, one of the things that we're doing at Axiom is that we each one of our modules will be a spacecraft, because we get delivered to orbit either by SpaceX or Blue Origin, and then we have to rendezvous with the ISS and be berthed. So every one of our modules will have thrusters, and so we could potentially become a source of desaturation for the ISS once we're there.
Oh.
Which might become important. The Russians are certainly talking about not supporting ISS, after 2025.
Wow.
So for those who don't know what Axiom Space is, could you give us kind of a brief overview of what the company's vision is, and as well as how it kind of fits into our current space climate of LEO destinations contracts, Russia building their own space station? Where does Axiom Space kind of fall into that?
Yeah. So Axiom is building the world's first commercial space station. So it is a privately funded endeavor to build a commercial space station. Now, we won the opportunity to build our space station off of the forward node of the ISS, which is an advantage in a couple ways. One, we get power from the ISS when we're attached, and we can get some thermal control. And then early on, we can use the communications to the ground through the ISS. So it's kind of like going camping and you got running water and electricity. And it's not until we get our 4th module attached to the ISS that we then can be independent of the ISS. We'll have our own solar arrays and ability to generate adequate power and thermal control. We'll have an airlock. And so a couple advantages. So it's very similar, very analogous to how NASA supported SpaceX and others in developing commercial launch capability. So there's a real business case for NASA to get away from the ISS and to have a commercial destination. And so of the $3.5 billion a year that NASA spends on the ISS, only about 500 million of that is spent on science and technology development and human physiology assessments, and the rest is spent on just maintaining the ISS. So if there were commercial destinations, then NASA could continue to spend the 500 million on science and technology development, but it frees up 3 billion to go on to the moon and Mars. So there's a real business case for NASA to help promote low Earth orbit destinations. And so that's the contract that we have. And the contract doesn't pay for development of the station. It really pays for insight. So, NASA, of course, is very interested when we're attached that when we turn the lights on, it doesn't dim the lights on their side, and we're sharing atmosphere. So they want to understand how we're scrubbing CO2 and generating oxygen. And so there's a whole bunch of requirements that come with being attached to the ISS. And so this NASA contract that we have really pays for us to provide them the insight and information and data so that they can be comfortable that it's okay for us to come and be attached. And then, of course, from a business standpoint, for us, it's an opportunity to be neighbors for a while, for a few years. And then we hope that come the end of ISS life, that we are the logical place for NASA to continue to do science and technology development and fly NASA astronauts. In addition, though, we really see an amazing opportunity in commercial space in lots of different areas. One is certainly flying private astronauts, but we think the big opportunity is in space manufacturing. So being able to make things in space that you can't make on the ground. And there's been a lot of promising experiments on ISS. There's a fiber optic cable that has 100 times more transmission length. It's been demonstrated on ISS, doing bioprinting of perfect retinal implants. But NASA is not really allowed to commercialize those things or to build those things at scale. And so having a commercial space station, we're able to take some of those promising technologies and make them at scale for customers. So in the future, we might build an entire module for a customer so that they can scale up some manufacturing process. And we really think that, 15 years from now or 20 years from now, we're going to have all kinds of objects in our lives that we can't imagine how we lived without them. And they will have been manufactured in space, manufactured using that unique microgravity, whether it's some kind of special alloy or perfect retinal implants or some kind of protein crystal that allows better drug discovery. So that's our main goal, is to provide a place where companies can really develop that manufacturing technology.
So the transition to the private industry has a lot of opportunities in terms of how you make something and sending it up to space. Are there going to be some major technological advancements and upgrades of an Axiom space station compared to the ISS?
Yeah. So we're certainly using a lot of lessons learned from the 20 years or so of flying ISS. And of course, our CEO is the former program manager of the ISS. He ran the ISS for about 11 years. So he knows all of those lessons learned for sure. So in many ways, we're trying to simplify things. Here's an example. When I built that GNC lab where we, for the first time, had the US GNC flight computer talking to the Russian flight computer. That US flight computer was $1 million Honeywell processor. we're not doing that. We're using a lot of processors that are used in automobiles today. A modern automobile has 80 million lines of software code, does a lot of processing. And so our flight computer is going to be about $3,000. And so we're just taking advantage of those kind of advances in various technologies, whether it's networking, computing, even robotics. We'll eventually have a large robot arm like the one on ISS, but the difference is quite stark in its capabilities, just because robotics has advanced a lot in the last 25 years. And so also some differences are just focusing on cost and designing for cost and designing for maintainability and upgradability, and really focusing on those things, because we have to build a station that's cost less to operate than the revenue we can generate from it. And that's not always what NASA's mission is, right? NASA's mission is solving a hard problem, and building the first ISS was a hard problem. And so there's lots of engineering solutions or choices that were made mainly just to solve a hard problem that end up costing a lot to do. So shorter answer is we're just focusing on really what's out there, and using a lot of non-traditional aerospace things, like using automotive parts and solutions from other industries.
So I know you also have a couple missions contracted for the Crew Dragon to bring Axiom astronauts. I believe the first private astronauts to the ISS. How does that kind of fit into the Axiom Space Station and where y'all are going as a company?
Yeah. So we, in addition to the port award that allows us to build our station off of the ISS, we have an agreement with NASA that allows us to fly private astronauts to the ISS. And our first crew will go February of next year, and 4 people. One is a former NASA astronaut, and the other 3 are private astronauts. And so it has a few functions. One, it allows us to really exercise our training for private astronauts, our mission control, and how we interact with the ISS during those missions. So it's in many ways sort of a precursor to how we want to fly our private astronauts to our own station. So it helps us learn how to do that. And then there's just a very practical reason too. It provides revenue for us, and allows us to develop that part of the industry as well. Because we do think that in addition to manufacturing, and we really believe that manufacturing becomes the dominant reason to have a commercial station, but there's also in the near term opportunities to fly private astronauts, and of course a lot of those are high wealth individuals, but we also are talking to lots of folks that their country doesn't participate in the ISS, and they still want to fly their own astronauts, whether they're in the Air Force or for that country. But there's lots of interest in other countries flying their astronauts to for their own country's prestige or for their own technology experiments and development.
Does the ISS have life technically till 2024 currently?
Yes, there is I think a bill that's in Congress to extend the life to 2030. And so somewhere between 2028 and 2030 is probably where the end of ISS life ends up. And our plan is our 4th module flies in 2027, into 2027. And so we want to be prepared for and have our full capability by the time the ISS life ends.
Curious how dependent you are on the ISS in the early stages, and then what's your timeline for being fully independent?
Yeah. So the first module flies in September of 24, and then the next 2 are about 6 to 9 months each after that. And we don't get full capability until the fourth module. So the fourth module is our power thermal module. So it has large solar arrays, allows us to generate about the same amount of power that the ISS can generate. Also has an airlock so that we can do spacewalks to do maintenance and things like that. So we're relatively dependent on the ISS for a couple things. Power, when we're attached, thermal control, and then at least for the first two modules, the space to ground communication, where we route that through the ISS. We'll have our own capability to do space to ground communication in our third module, potentially as early as the second module. So those are the three big areas that that we need the ISS for. Now we can generate enough power to sort of keep alive, without the ISS. But if in order to do experiments, to host astronauts, we need the power from the ISS.
And what is your background currently?
It is actually a rendering of crew quarters. So the first two modules will each have 4 of these crew cabins. So each crew cabin has a window that looks at the Earth and a infotainment center, some interesting storage. So we actually have a couple mock-ups of this, and we have some soft goods engineers figuring out how to make these blankets that are integrated with lights and things like that.
Well, you're going to make current astronauts pretty jealous on the ISS.
Right. That's been an interesting problem for me that I hadn't faced in all of my career, which is designing something for a certain aesthetic as well, right? All of my previous careers is building stuff that has functionality, and you don't worry about so much what it looks like. And so for our station, though, we're trying to pay attention to that, because another thing we think is a market is people want to fly products and do commercials and product placement and things like that. Another area that NASA is not allowed to do. And so having a more aesthetic look to the station is one of our goals. And also it's, if you look at the ISS, picture of the inside of the ISS, it looks like a crazy person's garage. There's just stuff everywhere. There's wires everywhere. And we think that having a cleaner look also reduces how much training you have to do. And we're going to try to be smart about interfaces where all the interfaces look the same, whether it's a life support box or an avionics box. They all open in the same way. I tell my engineering team that our goal should be to be able to completely dismantle the station with just 5 tools. And so trying to promote those kind of goals in building our station is important.
So space tourism has been something that's kind of been a dream for a while, and now starting to become more reality with Richard Branson's Flight Today and such. Is Axiom realistically the first space hotel?
Yes. We don't like saying that, because we really do think that the opportunity that we're building is this manufacturing base that is going to change the world. We're going to figure out things to make in space that will change the world. They'll make life better for everyone. Now, along the way, there's going to be some space tourism and hotels in space and movies made and probably some crazy things like 0G ping pong and other sporting events that get done in space. But I think all those things are a small part. I think there's some really interesting, just real work and real products to make that make life better for everybody.
You guys are in a really interesting position because, as far as I'm aware, there's no government plans to build another space station. So sort of in 10 years, Axiom Space Station might be the only US space station. So what does that mean for y'all in terms of responsibility? How are you working with the government with that? I also remember, this is a long question, but I remember there being some rumors of like maybe you guys taking some modules from the current space station. Is that still a plan? And sort of how does that feel to maybe be the sole remaining space station in 10,
Yeah.
15 years?
Well, it's certainly a great opportunity, and that's why we're so pleased to have this to won this contract with NASA to build off of the ISS, because it creates that relationship so that we want to be able to build the station that NASA would want to use. So, and one way we're doing that is we're looking at the current experiments and the current capability on ISS and figuring out how we would be able to just pass that through the hatch and install it on our side. And we're using the same berthing mechanisms so that we could take modules from the ISS that made sense to take. And there may be some, like even from like the European Space Agency. We're in some discussions with them about, what does their future look like after ISS, and they want to have their capability. And of course, there's a Japanese external laboratory that's on ISS, and certainly interested in keeping that going as well. So the shorter answer is we're working very closely with NASA and understanding the requirements that NASA and NASA's partners have in terms of technology development and experiments in space. And we want to be able to provide at least or better that capability.
I believe the ISS might be the most expensive man-made thing ever. What does that mean to one, be trying to bring that to its private side and do that in a cost-efficient manner? And on the flip side of that, what do we do with an old defunct space station, essentially? What is like the future of the ISS post 2030?
Yeah. So once funding ends for the ISS, NASA will put it on a trajectory that puts it into the Pacific Ocean. So it's going to be a spectacular reentry, and will mostly burn up, but there'll be parts that make it to the ocean. So that's the end of ISS, and NASA will want to do that in a controlled manner. You don't want to just abandon it and have it land on Los Angeles or Washington, D.C. or Paris. So it'll be put on a controlled reentry. As for the cost, generally estimated about $100 billion to build. So we certainly aren't going to spend $100 billion. We're actually going to probably spend 1/100th of that. And it seems like, well, how is that possible? And it's possible for a lot of reasons. One is just taking advantage of advances in technology. It's just, our flight computer is going to cost $3,000 and the flight computers on station cost $1 million. So there's just lots of examples of that where we're just going to take advantage of advances in technology. But also, I think it's important to realize that NASA has a lot of other constraints that aren't just about building a program. And so the International Space Station was as much about building a relationship between the US and the Russians as it was about building a space station, and also building a coalition of many countries, whether it's the Japanese or European Space Agency. So that comes at a tremendous cost in order to incorporate those other entities. So a lot of cost is because of that. And again, it's because NASA has other objectives other than just building a space station. And then the other piece, which isn't always appreciated, is just the funding profile. Especially in the early development years of ISS, it would have been much more efficient to be able to spend a bigger amount of money than was in the NASA budget. So the budget for the ISS program was relatively flat at $2.5 billion a year. But there were periods in the beginning where you really wanted to spend 10 billion, and then spend 1 billion in the subsequent years. But NASA just didn't have that luxury. And so there were a lot of things that were very inefficient in their development because of the funding profile. And so all those things together end up with a $100 billion ISS. And so we just don't have a lot of those constraints as a private company. You know, even things, and this is a bit cynical, but it's the truth, is, you know, NASA also divides work across congressional districts, right? There's a reason that part of the ISS is done in Alabama and in Houston and California, you know, because there's lots of congressional interest in having jobs in that particular area. And so all those things cause inefficiency too. It's just harder to integrate when you have your workforce spread across lots of different places in the country. It's not what you would normally choose to do. And so again, we don't have that constraint, and so we're able to do things more efficiently.
I think one of the common digs at NASA is like the biggest job creation program in the history of the United States. So I'm curious, where do you guys see yourselves in, 20 years? Are you having one big space station? Is it multiple different space stations, different orbits? Can you send one to the moon? Where do you guys see yourselves in 20 years?
Yeah. What we're focused on building is we want the capability to fly humans in space. And so we're building an engineering team for the long haul that can do that, can solve that problem, which is a difficult problem. There's only been 3 countries in the world that have managed to marshal the resources and technology to do that, to solve that problem. So we want to have that capability. And so then that allows us to be flexible. If there's an opportunity to build a space station around the moon and to manufacture things that we're mining on the moon, then we'll do that. If it makes sense to build a really large rotating space station that creates some artificial gravity that might house hundreds, if not thousands of people, then we'll do that. But we really think that the next 20 years and really the next 50 years, we are building destinations in space, and those destinations are going to look a lot different than what we're currently building, and they're probably going to be in different places than we're currently building. And one thing that is on our set of goals and we're thinking about is, how do you build modules different than how we're doing it now? Now the size of the module is constrained by the launch vehicle that we can send it on. So it's a certain diameter limitation, but we're very interested in how would we maybe manufacture a module in space, and therefore you're constructing it as big as you want it to be or need it to be. And how do you do that? And we're talking to some companies that have some interesting additive manufacturing or 3D printing capability, where maybe we're printing modules in space, and then also looking at inflatable modules and things like that. So I think the future station probably looks a lot different and probably has a lot of capability, but the core of our expertise is going to be, how do you build a human space system?
You mentioned inflatable modules, and naturally that makes me think of Bigelow. People might not think that like there is competition in creating a space station, but there kind of is. So can you talk about what sets you guys apart from your competitors?
Yeah. One, I think we certainly have some expertise and great leadership that has expertise in this area. The opportunity to build our station off of the ISS, again, is an advantage. It's just easier. We don't have to have everything. We don't have to have solar power right away. So it literally is like going camping and having running water and electricity. We can build our station in stages. We're well funded. So I think those are our advantages, but we're not naive about competition. And really, our natural competitors are the richest man in the world and the second richest man in the world, right? Elon Musk and Jeff Bezos, if they look up one day and say, hey, these Axiom folks are really onto something about this in-space manufacturing. They have tremendous resources to throw at the problem, and certainly are working, around this area. So we're certainly not naive that there is competition, but we also realize, though, that if the market really is as big as we think, that the opportunity to do manufacturing, then there's room for lots of players, right? And there will be lots of folks that are building stations and doing manufacturing in space. And that's really a good thing, right? It's sometimes you don't want to be the only person developing something, because that might be a sign that the thing you're developing isn't viable.
Right.
So in a past episode, we had Jaw on our podcast, who is kind of a leading expert in space junk and current LEO orbits. So I guess in terms of going and manufacturing in that orbit, how does kind of space environment and keeping that area clean play into what you do?
Yeah, no, I think it's a huge issue that the whole community has to address. So, we have to be very cognizant of our responsibility to not create a bunch of space junk. And so right now we're not, but it's easy to conceive that there might be some manufacturing process that somebody wants to undertake that might create a bunch of junk or things to throw away. But it's certainly a big problem that needs to be addressed and solved. And whether that's going and building something that scoops up the debris, which is a hard problem, but certainly managing the environment so that we don't create any more than we have to, and the Elon Musk's satellite system is certainly putting up a lot of satellites, right? I think he's well over 1,000 now, and he deorbits some pretty regularly, but managing that whole environment is going to be important. And I think it's a problem that no good solution at this point.
I think you mentioned that when you were younger, you always wanted to be an astronaut. Do you plan on eventually going to your own space station?
That would certainly be a fun thing. I would certainly not shy away from that opportunity. We think that at some point there's probably a transition. So, right now it takes a lot of money to buy a ticket to go. But we think that there's some period where it becomes more like working offshore, like on an offshore drilling rig, where specialized training and specialized expertise and relatively hard to get there, but people are sort of routinely doing work there. And then the next phase after that is where, you can go and buy a ticket for a reasonable price and take the family to space. But we're a bit of a ways away from that next stage where there's sort of the common engineer or worker in space. But I often joke that I'm going to put some system on the Axiom station that requires my thumbprint to activate.
Yeah, maybe in 10 years, that won't just be a Zoom background. That will be the real deal.
Right.
I'm wondering, since you have experience at both NASA and now the private space industry, what is sort of the biggest operational difference that you see, like maybe besides the funding aspect? Is there like an organizational difference?
Yeah, I think certainly NASA has a long history of capability. So one of the things that have been a challenge for us is, one, we have to build a team. So we have to find all these experts across pretty diverse disciplines for a spacecraft. But it's also building all the laboratories and test facilities, so all that stuff exists at NASA. And so figuring out how to build all that has certainly been a challenge. But I think in general, organizationally, we're able to be leaner. We get to create our own organization, And in big institutions like NASA, the organization just is there and it's always been there. And there's a certain level of organization, and it's just hard to change that. So we just have an opportunity that we can make decisions faster. We don't have as many people that we're accountable for to. Our people, I think, have probably more individual responsibility because we're a smaller team. At NASA, there might be 30 people that do stress analysis, but at Axiom, there's two. And so there's just a lot more responsibility personally. Um, so I don't know if I answered the question very well, but those kind of organizational differences. I think the biggest problem with a organization that's been around for a long time is there's just a certain momentum and inertia that's hard to get away from. I mean, it would be impossible for NASA to go and say, "Hey, I don't want to have these 6 levels of management anymore. I want to have 3." You just can't do it. It's just too hard to do.
For sure.
So, as CTO and an engineer by trade, what would you say is the hardest part of building a space station?
I think the hardest part is that there's all of these interactions, and it's a very multidisciplinary problem. Um, we have to have a guidance and nav system, and that means we have to have a propulsion system, and then the propulsion system has high pressure. And how do you make sure those things, don't affect the crew in the cabin? And when we have crew in the cabin, we have to generate oxygen, we have to scrub CO2, we have to monitor for trace contaminants, we have to provide food and water and hygiene. And it's just a complicated, multidisciplinary problem. And I think that's really the challenge. The individual technologies, whether it's avionics or structures or propulsion, they're not science problems, they're just engineering problems. But and each of them individually is pretty manageable. It's really the whole problem. It's all the multidisciplinary, how do you build the thing and have everything come together at the end is the challenge.
So, I know crew resupply is a huge part of the ISS. Is there a future that you see where we have a self-sustaining Axiom space station?
Yeah, we're certainly trying to close the loop to the greatest extent possible, and certainly beyond what's been done by ISS. So, we're recycling water and turning urine back to water. We're going to try to manage our trash and get all the water out of all the trash so that we can minimize the resupply. But there will always be some resupply required. You still got to fly food up. And although we're also looking at growing food, it's just a hard thing. It takes just a lot of area and space and volume to grow enough food to be sustainable. But one of the interesting things we're doing also is that our propulsion system is a methane and oxygen system. And so we're going to take the CO2 from the crew, the exhale from the crew, and we're going to take the CO2 and turn it into methane through what's called the Sabatier process. And so our calculations show that when we have a permanent crew of about 6, we can generate all the propulsion that we need just from their exhaling CO2. So that's going to be a huge game changer for us. So we will get to a point where we'll never have to fly up any more fuel. And in fact, once we get more crew than that, we can generate excess fuel that we might be able to create a business with and refueling satellites or space tugs and things like that.
Wow,
But
that's one
there'll
that I've
always
never
be-
heard before, and I've never heard you talk about before, actually. And I think that's massive. I mean,
Yeah.
so what is do you plan on changing orbits with this fuel? Your station keeping?
Yeah, it's station keeping, debris avoidance, maneuvers. And then also, there may be one difference about our station too is because every module is its own spacecraft. There may be times where, or we may get to a point where a particular module has passed its life or is not usable anymore. So we can detach it and then have it controlled reentry into the atmosphere. But also, we think we're going to need some reentry modules. You know, if we're successful at manufacturing things in space, we're going to need to bring them home. And so creating fuel for those kind of vehicles, as well as vehicles that may change orbits. You know, maybe there's an opportunity to manufacture geostationary satellites in space, and then, you know, you got to boost them up to geo. And then there may be some point where we have a particular manufacturing process that is either very hazardous or maybe very, very sensitive, where even a crew person pushing off the wall, excuse me, would affect that manufacturing. So we might have modules that separate from the main station, do their manufacturing, and then reattach and get unloaded and then reload the raw materials. So there might be all kinds of those sort of things that require some propulsion capability.
So how long do you expect a module to survive?
Yeah, you know, we're generally designing everything for a 30-year life, but knowing that we want to be able to upgrade the avionics and computers every 5 years like you do your laptop. So we're building a lot of upgradability into the systems as well. So that could mean that it has really indefinite life. The hard structure generally is designed for a 30-year life, and then you just have to do some analysis at some point to prove that it can go beyond that, which is what's been done on ISS. You know, it's really beyond its original design life in many areas, and so lots of work was done to make sure that you know, the life extension was viable.
So is the first Axiom module currently being made in Houston?
It is currently being made in Italy by Thalassania. So Tazi has built about 50% of the modules on ISS. And so they're building the first two pressure vessels, the primary structure. And so they were the right choice because they have all the tooling and have a giant friction stir welding machine that can make these pressure vessels at that size. And then they will ship the primary structure to Houston, and we'll do all the final outfitting and assembly in Houston. So everything else is generally done in Houston, and it'll actually be part of our Houston Spaceport facility. So Houston has one of the 11 approved spaceports as part of the Ellington Field Airport. And so we are building our ultimate facility at the spaceport. We're going to break ground this year and be available in about 2 years. But that facility will house all the teams, all the engineering capability, all the laboratories, all the manufacturing, and we'll do the final assembly of the modules there, and then roll them out the door and load them onto a plane and take them to the Cape for integration with the launch vehicle.
Is the goal to eventually bring all that manufacturing in-house or stay with the Italian manufacturer?
Yeah, the goal is to bring it in-house. It's another big undertaking. And so at this point, it's just a problem. We just don't have the bandwidth to solve at the moment. But yeah, we really think in general, our philosophy is to do as much in-house as possible. It just gives you greater control over your own destiny. It's really the SpaceX model and Blue Origin. You know, they're doing most everything in-house, and so we want to do that as well.
So are you allowed to tell me like what percentage of your funding is public versus private?
It's almost entirely privately funded. We did a Series B round that we closed in January, and it's publicly known. We raised 130 million. We're going to raise probably 3 to 4 times that this summer in the next round. And then actually we'll probably go public after that. And the public round will provide all the funding we need.
Do you have an idea of how big you expect this market to be, like when you first launch your station?
Yeah, it's one of those things that's hard to predict, but we think it's hundreds of billions of dollars, and a combination of private astronauts, manufacturing, marketing, public, product placement, all those things combined, we think are hundreds of billions of dollars, but it's such a hard thing to predict. It's sort of like trying to predict how big the internet was going to be in 1990.
And there's so many new launch providers like coming into market. Um, you have, I think you mentioned that you can launch on Falcon 9. Are there any other launch providers that you can launch with? And are you trying to make it like so that you can be adaptable?
Yeah. We're protecting to launch the modules on either the SpaceX Dragon Heavy or the Blue Origin new plan.
Okay.
Blue Origin just announced sort of a slip of their schedule to late next year for their first launch. So we may end up having to launch on SpaceX for the first couple, but we want to, have options. And so we're protecting to fly on either one of those.
What excites you the most about Axiom in the next 10 years?
I think one, I get excited about building the team, and I often talk about and have people imagine 4 years from now when we're all down at the Cape and we've just launched the first module and it's just been birthed, and how exciting that's going to be. It's a really an amazing thing to take this idea and create something in the world, right? And especially something of that complexity. So that's going to be really fun and interesting experience to go from literally an idea on a napkin to space hardware, and especially space hardware of that complexity. So excited about that, but really excited about how we're going to change the world. We're going to figure out things to manufacture that 20 years from now we won't know how we live without. We're going to create new materials and new things that we can't imagine how we live without, and they all will be made in space.
Yeah, it's like the App Store, right? They didn't
Yeah.
know what sort of apps would be developed, but they just created the platform,
Right.
let it, nourish. So it's interesting because you can't even imagine like what you're going to allow,
Right.
and that's just a crazy thought.
Yeah, no, it's exactly right, and we use that analogy actually a lot. And also, if you think about, there's been some experiments that have flown on ISS that show, again, you can make a particular kind of fiber optic cable that has 100 times more capability. And there's other things, but there were probably hundreds, if not thousands, of other ideas that never went anywhere because there was no place for them to go after the ISS experiment. So there were probably hundreds of people that thought, well, I could spend $1 million and fly this NASA experiment on ISS, and if it proves to be a viable thing to manufacture, well, then what am I going to do? I don't have any place to go manufacture it. So there were probably hundreds of those that never went anywhere because of that. And now we have an opportunity that if it is viable, well, we can manufacture it. We can build an entire module for a customer to manufacture that thing. And so I think because of that, it's just leads to all kinds of opportunities that we can't even imagine right now.
What advice would you give to an up and coming engineer who wants to be a part of a company like Axiom that is changing the world?
Yeah. Apply. We certainly are hiring. We're trying to add another 100 to our engineering team by the end of this year. But I think, if you're interested in space and you go study the right things, mechanical engineering, electrical engineering, aerospace engineering, it's such a multidisciplinary problem that no matter what your interest is, if you like, electrons, or if you like design and structure, there's a place for you. Companies like Axiom for sure.
So can we get a free night on an Axiom Space station? Is that part of this deal?
Hey, maybe so.
Well, I think that's pretty much all I got. That was a lot. I want to thank you so much for coming on, spending an hour of your
Sure.
Sunday with us.
Sure.
Yeah, this was
Especially
fantastic.
during Richard Branson's flight. I know that was an exciting moment.
No, I appreciate it. It's fun.
Yeah, maybe one day we'll have to stop by at the new Houston facility. It sounds like y'all
yes.
doing a lot of really cool things.
Yeah, for sure. Definitely.
Well, thank you again, and I hope you go enjoy your Sunday.
All right. Thanks.
Thank
Appreciate
you.
it.